Yes, good afternoon students. So this is the second part of Z effective. We are discussing about the effective number of the atoms present in the unit cell. So in the previous video we have seen about the simple cube, then the BCC and the FCC and the number of the atoms which are present in it, right? Now let's discuss about the Z effective formula, right? So first thing, if you consider an atom which is present at the corner, ज्यावेळेस ऍटम हा कॉर्नरला असतो त्यावेळेस तो त्या क्यूबचा कितवा भाग बघतो ते समजून घेऊया पण त्याच्या अगोदर क्यूबला नीट समजून घेऊया इफ यू कन्सिडर अन अ क्यूब राइट सो दिस क्यूब in this cube these are the corners so each cube consists of 8 corners there are 8 corners which are present in the cube right so to this 8 corner there is 8 atoms but that entire atom do not contribute to that unit cell. तो atom पूर्णपणे त्या unit cellचा भाग नाहीये. The atom which is present at the corner is shared by 8 unit cell. Is shared by 8 unit cell. म्हणजे तो atom जो आहे जो कॉर्नरला असतो तो ऍक्च्युली 8 युनिट सेल मध्ये डिवाइड होतो किंवा शेअर केला जातो. मग आपण जर म्हटलं so corner the number of atoms you can simply say the atom which is present at the corner only 1/8 part is actually the part of the unit cell right मग इथे जर तुम्हाला number of the atoms find out करायचे असेल number of the atoms at the corner if you have to find out your formula will be NC by 8 it is simply NC by 8 कारण त्या ऍटमचा फक्त 8वा भाग हा ऍक्च्युअली कुठे प्रेझेंट असतो त्या युनिट सेलच्या आत समजलं मग जर तुम्हाला तिथे नंबर ऑफ द ऍटम्स प्रेझेंट दी कॉर्नर काढायचं असेल तर फॉर्म्युला काय होईल मग आता NC by the 8 ओके सो दिस वाज फॉर द ऍटम which are present at the corner now for the atoms right which are present at the faces so for the atoms or for the atoms which are present at the faces when you talk about the faces you should know one thing in each cube there are actually 6 phases there are actually 6 phases so whatever I have drawn actually this spheres or the atoms which are present in the phases so there are 6 phases okay if you say that there are 6 phases then the but the sphere which is present at the face is not entirely part of that unit cell म्हणजे पूर्ण atom किंवा sphere तो फेसला जो प्रेझेंट येतो त्याचा भाग नाही जर तुम्ही हा युनिट सेल कन्सिडर केला आणि हा जर ऍटम आहे की जो फेसला आहे तर त्याच्यातला फक्त हाफच भाग हा त्या युनिट सेलला कॉन्ट्रीब्यूट करतो ओनली हाफ पार्ट ऍक्च्युअली बिलोंग्स टू द युनिट सेल मीन्स atom which are present at the faces are shared by the 2 unit cells so that means only half part of the atom belongs to the unit cell so there are 6 phases and therefore there are 6 atoms but that 6 atom only half part belongs to the unit cell so it will become what 6 into the half right but when you have to generally calculate about the number of the atom present at the phases you can go for the formula so number of the atoms at the phases will be given by the formula it will be NF by 2 right means when you have to calculate about the number of the atoms which are present at the faces the formula will be NF by 2 where this was I'm taken here that there are 6 phases so I have taken all 6 phases right see it may vary म्हणजे ते आपल्याला न्यूमेरिकल्स देताना सांगतात की 2 ॲटम फेजेस चे कमी आहेत कळते का मग तिथे तुम्ही 6 नाही घेणार तुमच्याकडे 4च फेजेस शिल्लक राहतील so you have to modify that so for the general terms you can use the formula as NF by 2 okay so this formula was for the phases atom now next is ages let's talk about the ages So if I say about the edges, there are how many edges? See these lines, whatever you are seeing, these lines. These are called as the edges. हे जे lines तुम्हाला दिसतात हे सगळे edges आहेत. मग जर हे नीट पाहिलं तर असे किती edges आहेत त्याच्यामध्ये? There are 12 edges. How many edges are there? 12. So in case of the edges are 12 in each cube, right? But when we talk about the edges, what happens? Then this is the edge, okay, and this is the atom. So the part of the atom which is present at the edge, which contribute to the unit cell, is the 1/4 part. So at the edges, 1/4 part of the atom actually is a part of what? Of the atom is a part of the unit cell or contributes to the unit cell, right? So in the edges, only 1/4 part of the atom contributes to the unit cell. Okay. So you can simply, therefore, you can say, so the number of the atoms at the edges will be given by the formula Ne by 4. So the formula will be what? Ne by 4. So this is the third point actually we are discussing, that is about the edges, right? So there are actually, or you can say only 1/4 part of the atom actually which is present at the edge is a part of that unit cell. Therefore number of the atoms at the edges will be given by the formula Ne by 4. So next is the body center. Next is the fourth point, that is the body center. When you talk about the body center, means that atom is present at the center of the cube. Now the important of this is what? This atom is not shared with other unit cell. It is totally the part of the that particular unit cell. So you can say it is not shared. It is not shared, right? With the other unit cell. With other unit cell, right? So you can say that for the number of atoms at the body center can be given by the formula Nb by 1. It is given by the formula Nb by 1. So this was for all the different positions where the atom can be present. So depending upon this, if you take the sum of all these atoms, your Z effective formula can be therefore given as Z effective is equal to Nc by 8 for the atoms which contribute at the corner position. Next, Nb by 1 for the atoms which contribute when present at the body center position. Next, Ne by 4 for those atoms which are present at the edges, right? And Nf by 2 for the atoms which are present at the faces position. So this was about the Z effective for the different positions where the atom can be present. So the Z effective is nothing but the sum of the portions of the atom which are present at the different position but which contribute to that particular unit cell. Okay, so this was all about the Z effective. In the next video, yes, the third part of this video, we are going to discuss about the other positions where the atom are present, right? Other than this. So let's continue for that video. I'll stop here.